I love cookies, and I love to dunk cookies in milk or tea. But sometimes when I do that, I get my fingers wet or burnt if the tea is very hot, and this is a very unpleasant experience that can ruin the whole ritual. So I decided to end this problem once and for all by creating a Lego machine that can feed me cookies after dunking them automatically. Let's do it. The first step is to decide on the specs I want my perfect cookie dunking machine to have. First, it needs to be able to dunk at least 4 cookies, which is the maximum I usually have before going to bed. Second, all mechanisms need to be powered by a single motor. Third, I want to use just one hand to carry and operate the machine. Fourth, try to use only official Lego parts so anyone can replicate the device with the instructions I plan to create. And fifth, I want the machine to be compact and use the least amount of parts as possible. Okay, now I need to break down all the movements required to dunk a cookie, as each movement will need its own mechanism. The movements are: first, load cookie. 2. Push cookie forward into dunking mechanism. 3. Dunk cookie. 4. Eject the cookie. And 5. Of course, eat the cookie. 2 things will determine the overall dimensions of the machine: the size of my Grumo coffee cup, which is 98 millimeters tall and has a diameter of 83 millimeters, and the type of cookies I want to auto-dunk. For the cookies, I already have some which are 48 millimeters in diameter and 16 millimeters thick. But instead of wasting real-life cookies, I decided to create 4 dummy cookies with similar dimensions made of cardboard circles glued together. Although they turn out much lighter than the real cookies, for the most part, they should be good enough to help me build all mechanisms. Let's start with the first mechanism, the loader. My first idea is to build a gravity loader. However, I realized the cookie stack would stick out too much over the top of the cup, making the whole device too tall and compromising my compactness requirement. So I decided to build a scissor hoist. This way, the cookie stack can fit below the rim of the cup, making the device more compact. The concept seems to do exactly what I want, but now I need to devise a way to operate it. I decided to make it spring-loaded so it will work like a gravity-fed loader, but in reverse. For a spring, I steal one of my wife's hair elastics and it works like a charm. Thanks, Beth. I was concerned about the crucial cookie dunking step. I thought I would have to create a complex mechanism to grab each cookie, but then I figured out a simple solution would be to use just a pivoting ramp with a hook to hold the cookie in place during the dunking motion. Now, I proceed to create the structure that will hold the dunker ramp and cookie loader in place. Then I add a lever mechanism to operate the dunker ramp remotely. Now, I build a rotating arm to push the cookies from the cookie stack onto the dunker ramp. Next, I attach an eject ramp and another swivel arm to eject each cookie after being dunked. I test the whole loading, dunking, and eject sequence manually, and it works. Then, I discovered that a single arm can both load and eject cookies. Yeah, I love simplicity. Next, because the hoist is spring-loaded, I need to build a stop to prevent the cookies from flying away. But when I test it, the loading arm gets stuck and has trouble pushing cookies from the stack. So I lower the spring tension on the scissor hoist. But then, even after applying some lubricant, the hoist gets stuck half of the time. So as much as I love the simplicity of the scissor hoist, I decide to scrap it in favor of a ratchet hoist. It's more complex, but it works great. Here's how the indexing mechanism works. And here's the ratchet mechanism. It's amazing what you can build with Lego. The new ratchet hoist works well with the dummy cookies, but because it has a fixed pitch per cookie, I realized it won't work well with the real cookies, which, when stacked, are clearly thicker than the dummy cookies. I need to find a thinner cookie. Turns out Oreo cookies at 12mm thickness are perfect for the new hoist mechanism. Now that all 4 mechanisms work well independently, I have to connect them using a single rotating input. It took many hours, but I figured out. Let me show you how it works. First, the main input lever raises the cookie stack and loads a cookie. Second, the same input lever pushes down on the loading lever, which pushes the cookie into the dunker ramp. Third, the main lever activates the dunker ramp lever, which lowers the ramp and dunks the cookie. For the fourth final step, a second input lever arm activates the cookie eject mechanism and the cookie flies into a cookie-hungry mouth.
Thank you.
It's time to power this beast with a single motor. I got lucky and a simple worm gear transmission had enough torque and the perfect overall speed for the entire mechanism. Finally, I wanted to be able to operate the device with a single button and a single hand. I settled for a push bar mechanism which I could operate with my thumb while still holding to the cup. And with this, the cookie dunking machine was completed. The whole thing took 3 days to build and I'm super happy with the end product. It meets all the original specs. Well, almost. So what should I call it? I was thinking to call it DUNKY, the ultimate cookie dunking machine by Grumo. Do you have any other name suggestions? Let me know in the comments. Now it's time to test it in the real world with real cookies, real milk, and a real cookie-loving human person. Let's do it. How cool is this? If you want to build your own cookie dunking machine, check the description for a link to the step-by-step instructions. And if you want to see more videos like this, like and subscribe. And now, how do you drink this?